You're welcome. You're welcome. Please give me a few minutes to get myself ready to join you. A few minutes, please. You're all welcome. If you're just joining us, you're welcome. Please do well to like the video if you're just coming online. Do well to like the video. If you're just joining us online, do well to like the video. If you're just joining us, please write your name and the lecture you're watching from. Your name and your lecture, and do well to like the video. Those are the three things I want you to do for me right now. Your name, the lecture you're coming from, and also like the video. Please do that now. Your name, the lecture you're coming from. Do that in the comment section. Type your name and your lecture and like the video. And for those who are just joining us, do well to write down this question. There's a question on the board. Do well to write it down. Thank you so much, Psycho from Solid. You're always with us. Thank you. Damilola Lalande from Legend Solid. Okay, you're welcome. Godwin Omusi, Gift from Cambridge, you're welcome. Charles from Brainford Lectures, BIU branch, you're also welcome. Please, all of you, do well to like the videos if you're just joining us. Like the videos right now. If you're just joining us, your name and where you're coming from. Obey from Cambridge Lecture. Eugene Adams from Cambridge Tutorial. Please, Eugene, my regards to, I don't know, someone called me and he mentioned your name and he sent me an airtime worth of data. Please, help me appreciate the person. Eugene Adams from Cambridge Tutorial. Thank you so much. Someone called your name and sent me airtime. I'm really, really grateful to that person, okay? Osarubo Blessing from Starbridge Tutorials, you're welcome. Oh, Kelvin, Olise Kelvin, thank you so much, Kelvin. I really do appreciate. You're one of the reasons why I'm live right now, so I really, really appreciate. So please, if you are just joining us, just like the video. That's all I ask of you. Like the video so that it can go far and other persons can join us on this live. We're going to be dealing with past questions today. Secondly, I want you all to look at the question on the board and write it down. Look at the question on the board and write it down, and also help me check if it is very clear, please. If you can see it clearly, please write it there so I would know. All right, I have to use my mic today so you can hear me clearly. So we are going straight to business in the next 1 minute. Before then, please, if you know you're just joining us, do where to like the video. Do where to like the video right now. Good evening. Your name and the lecture you're coming from also. So I have all questions from 2023 physics, and we're basically going to be looking at those questions today. The first question is the question that came out in 2023 JAM, and that's it on the on your screen right now. It's written on the board. And okay, thank you, precious Oledibe. All right, so please do it to like the video, okay? All right, thank you very much. I'm honored to be with you all. So I want to know if you actually saw my face so that I can rearrange the camera. If you know you saw my face clearly, please let me know. Type it on the comment section right now. I thought the board was straight enough. All right, did you see my face just now? Did you see my face just now? Okay, is there any adjustment we need to do, or can we start up? Okay, so how about now? Is it better now? Promise from Starbrain Wasota, you're welcome. Okay, how about now? Is it better now? All right, so is it better than before? Please let me know before we start. Is it better than before? Please, if you're just joining us, please click the like button, please. When you click this like button, you attract more people. Now, another thing you're going to do for me, if you look at your screen, you're going to see 3 lines on your screen. I want you to click that line and share the video to your status. I want everybody here to share that video to their online WhatsApp status. Do that now. Click those three lines on your screen and share this video to your online WhatsApp status. Share it to the group where you belong to, whichever group you belong to in your lecture. Share it right now. You don't know the life you might be saving right now. This is 2023 JAM Pass question. It came out last year, and we are going to be reviewing each and every one of them. Save a life right now. Share it right now. Wealth from Cambridge, you're welcome. Share it to your WhatsApp status. Do that now. Click on the like video, click on the three buttons on your screen and share this video. Do that now, please. Tessie from Cambridge, you're also welcome. Tessie, do where to click on the three buttons and share the video live, please. All right, it's better like this. Okay, no problem. Your wish is my command. Of you to click the three buttons on your screen, share the video to your WhatsApp status, share the videos to every group you belong to. I want so many persons to benefit from this class. You just might be saving somebody. For those who can't see the writing, I'll read it out for you. The property of wave shown in the diagram above is. The property of wave shown in the diagram above is. The property of wave shown in the diagram above is. A is diffraction, B is refraction, C is polarization, and D is interference. I repeat, A is diffraction, B is refraction, C is polarization, and D is interference. So do that right now and write it down. The property of wave shown in the diagram above is A, diffraction, B, refraction, C, polarization, and D, interference. So welcome all those who just went off now to share the video to their status and their group. So we are ready to go on. Okay, so good evening all of you, and thanks for joining us tonight on this bright Sunday. And even though the Sunday was rough for me, I was still able to make it in time to still join you all. And for those of you who still kept the faith, and for those of you who supported and made sure I go home, I really appreciate. So at this point, we would like to look at this particular question, which was the very first question that came out in 2023 JAM. All right, now there's a diagram before me and there's a diagram before you also. This was the way they brought the question out last year, and they said the property of wave shown in the diagram above, meaning they are talking about this diagram, is option A is diffraction, option B is refraction, option C is polarization, and option D is interference. The answer to this particular question is diffraction. All right, the answer to this question is diffraction. Now, what is diffraction? Diffraction is one of the properties of waves. What does it entail? It is defined as the spreading or the bending of a wave around a corner after it passes through a tiny opening or aperture. Now, the distance between this and this is called an aperture, all right? APERTURE, aperture, all right? The distance between this is called an aperture. This is called a silt. A silt. A silt. While the space between these two is called what? An aperture. Now, when a wave passes through this tiny opening, it is set to spread. Now, take for instance a balloon, all right? What you Nigerians call bloom bloom. Take for instance a balloon. The mouth of a balloon is very tiny, but when you inflate the balloon with air from your mouth, you notice that the body of the balloon begins to expand. Now, the hole through which that air is going in is a tiny hole. It's usually very narrow, but after the air passes through that hole, what happens to the balloon? It becomes inflated, it begins to spread. So this is the hole of the balloon. This is the air approaching the hole. And when the air struggles to pass through this tiny hole, it becomes happy. Freedom at last. So it begins to spread out. That spreading of wave is called what? Diffraction. All right. You see some spreading this way, you see some spreading this way, and you see some spreading this way. So be in mind that if this question comes out in 2024 JAM and they ask you the property of a wave shown in this diagram is, do not waste your time. Choose the word diffraction. The answer to this question is diffraction. Thank you. Lucky keys, it's not interference. Lucky keys is not interference, it's diffraction, okay? Interference has to do with superposition of two waves, all right? When they climb each other, that's a different one. This is called diffraction. For diffraction, it spreads. Okay, now another thing I failed to tell you was diffraction is a phenomenon that was discovered by an Italian scientist who goes by the name Francesco di Grimaldi. He was an Italian scientist, Francesco di Grimaldi. Francesco di Grimaldi. Okay, it was actually discovered in 1661, whereby when you visit Google, sometimes they might tell you in 1663, others will tell you in 1666. But the actual date that Francesco di Grimaldi, the Italian scientist that discovered the phenomenon of diffraction, was actually in the year 1661. So that is another insightful thing you've learned today. And you see why you need to share this video, right? Others can benefit what you are learning today. Thank you. I'm running low on data right now, and I need to buy. All right, I'm back. So please, if you know, you can type it on the comment section now. If you can see the board, just type it's clear enough. I want to put the second question right now on the board, so I need to go off. But before then, I need to be sure you are with me on this live. So please and please, if you know, you can see this question right now and everything I've written on the board. Oh, thank you. Thank you, Psycho. I actually had this question somewhere else, but I forgot it in a rush. So I have to start picking the questions from my phone. It took me a very, very long time to compile these questions for you. So please don't play with it. Chris from Cambridge, you're welcome. Chris, please just hold on. You have not liked this video. Do where to like this video now. I'm seeing just 10 likes, which is not really encouraging. Do where to like this video now. Do where to like this video now. Just click on the like button. If you share, you can share the video. This is question number 2 on the board, and I want you to write it. Thank you. Thank you, Psycho. Thank you so much. These are the people who are really trying and making sure this gets viral so that others can benefit. People like Obey, people like Psycho, they are really, really trying. Thank you for the love. Thank you for the likes, please. Thank you so much for those of you joining us. That is actually the second question from JAM 2023. Please, if you've liked this video before, you don't need to like it again. If not, they are going to unlike it, okay? If you've liked it before, you don't need to like it again. Thank you, Godwin Onusi, for sharing. Thank you so much. I hope you didn't miss the first question. We're about to solve the second. In case you missed the first, you shouldn't miss the second. All right? So there we have it. I will try and read for, thank you, Kelvin Olise, for the sharing. Thank you so much. I really do appreciate. I'll try and read the second question. A missile is launched with a speed of 75 meters per second at an angle of 22 degrees above the surface of a warship. Find the horizontal angle achieved by the missile. Find the horizontal angle achieved by the missile. This is not actually supposed to be horizontal angle achieved. They made a mistake here. All right. It is supposed to be find the horizontal distance. All right. Correct this to distance, not angle. Find the horizontal distance achieved, not find the horizontal angle achieved. Find the horizontal distance achieved by the missile. All right, so I'm going to read it again so that everybody would have it. Okay, thank you, Alon Promise Ekije, for sharing this video. In fact, you guys are really doing a great job. Put it on your WhatsApp status. Just click on the 3 buttons. You see the share. Click the share. Take it to WhatsApp. Take it to Facebook. Take it to all social media platforms. So let people join this video. I need this video to be saturated. I want this to go far. I want so many persons to learn from this. A missile, I'm going to repeat this again. A missile is launched with a speed of 75 meters per second at an angle of 22 degrees above the surface of a warship. Find the horizontal distance achieved by the missile. And in the bracket, we're told to take G to be equal to 10 meters per second square. And the first option there, we have 195 meters. And the second option there, we have 271 meters. And the third option there, we have 391 meters. And in the fourth option there, we have 136 meters. I hope you have the question right now because we're about to solve. If you're just joining us, please click the like button. It's very, very important. Very, very important, okay? So we have the missile is launched with a speed of 75 meters per second at an angle of 22 degrees to the surface of a warship. Find the horizontal distance achieved by the missile. Take G to be 10 meters per second square. That's the acceleration due to gravity or free fall. And you have the options on the board. So I would want to go straight to solving this question. Now, this was the second question that came out last year. Remember, we had so many persons who wrote this exam. So they had to share the questions differently. So what I did was, during the duration of the exam, I made sure I went down to the exam halls, get this question, write them down, compile them, and bring them for you. You don't want to play with this. All right? So I'm going to have to take this off. But before I do that, I need to bring out the parameters, okay? So to solve this question, I love using my keyword. It's a powerful word called the antidote. My students, you know what this means. I'll tell you to always write antidote and smile before you solve any question because there's something powerful about it. All right, now let's move together. This question falls under a topic called projectile motion. I repeat, the question falls under a topic called projectile motion, okay? Now, what is projectile motion? It's simply the motion of a body or an object that follows or traces a parabolic path, okay? Now, we're told that a particular missile was launched with a speed of 75 meters per second. When you're launching something with a speed, it simply means it is just starting. That means that the velocity of launch is not the final velocity, but the initial velocity. And we represent initial velocity with letter U in physics. Now, what was the value of the initial velocity of launch? It was 75 meters per second. 75 meters per second. Now, after giving us the velocity of launch, we were told that this launch was carried out at an angle of 22 degrees. Definitely, that angle is called the angle of projection. All right? The angle of projection. Some persons might tell you it is called the angle of elevation. They mean the same thing because when you project something, it goes upward. When you elevate something, it also goes upward. All right? And that is represented by this symbol, theta. Therefore, the value of theta is 22 degrees. The value of theta is 22 degrees. All right? I just want it to be clear enough. The value of theta is 22 degrees. Now, we're also told that this was done above the surface of a warship. Those are stories. Find the horizontal distance. That tells us that the question wants us to know that the moment they release this missile and it lands, from where the missile was released to where the missile will land, there is a distance that is covered horizontally. It is that distance we want to look for. Now, that distance is represented by R. That word R means range, okay? R stands for what? Range. Now, what is the range? We are going to put a question mark because we don't know. Now, they didn't stop there. They also told us to take the value of G, which is the acceleration due to gravity. I said it before. Every object, provided it's in the earth, is always influenced by an acceleration due to gravity. And the gravitational force always pulls the body downwards. That's the way it acts. If you are going upward, you are going against the force of gravity. all right, there is going to be this force which is trying to pull you downwards, and that's why they said when you go up, the gravity becomes negative, and when you come down, the gravity becomes positive. So right now, the letter G, which is gravity, has a value of 10 meter per second squared. Now, the next thing now is to ask yourself, what is the formula for finding the range? Now, there is one good formula for finding range whenever theta is involved, all right? Now, the formula for finding the horizontal distance, which is also known as the range, is giving us R equals U squared sine 2 theta divided by G, all right? This is the formula for finding range, okay? You might want to put that on your pad, okay? You might want to put this on your notepad, okay? Now, your theta stands for the angle of projection, which is 22. Your U stands for the initial velocity, which is 65. Your G stands for gravity, which is 10. And obviously, we are looking for the range. So what I'm going to do, I'm going to pick these values, and I'm going to insert them into the formula. Now, the moment I do that, my range automatically becomes U is what? 75. So everything here will become 75 squared. 75 squared multiplied by sine, which is a trigonometrical function, 2 multiplied by theta. And now what's the value of theta? The value of theta is 22 degree. 22 degree. Now everything here is to be divided by G. And what's the value of G? The value of G is 10, according to what they gave us here, all right? So our range definitely becomes, I might have to use a calculator here in order not to waste much time. All right, I can see some of you have even gotten answer 391 from Tessico, okay? Right now, so 75, we're going to find the square of 75. That's going to give us 5,625, all right? 5,625 multiplied by sine, 2 times 22 will give us 44. And everything is going to be divided by 10. And definitely, all I need to do is to multiply the answer I have on my calculator with sine of 44. And that gives me 3907.45. I approximated to 2 decimal place, all right? 0.45 divided by 10. And at this point, I would get my final answer by dividing this with 10. So I press divided by 10, and I get 390.745. All right, definitely the unit is meter. And now if you check our options, it was in the form of a whole number. So I am going to approximate this now. I have 3, I have 9. Now I have a 0 here, but after the 0 there's a decimal point, and after the decimal point there's a number 7. The rule states that if you have a number within the range of 5 to 9, approximate that number or round off that number to 1 and add it to the preceding. Preceding means before. Now, if I approximate 7, I get 1. If I add 1 to 0, I get 1. So that becomes 391. What is the unit for the range? The unit for range is meter. And that becomes our final answer. So the range that was covered by this missile was 391 meters. Thank you. So Tessico was actually right. Tessie, you were correct. Thank you. All right. Please, if you're still here, please type a message, I'm still with you, sir. Or just type a message, I'm here. I need to know those of you who are following. And let me know if I'm going to be giving you the next question or if I'm going to be ending the live video right now. Your Barrow blessing is with us, okay? Yes, they won't give you scientific calculator. That's true. That's true. I'm working on another class where I would be teaching you guys how to solve without scientific calculator. All right. And if they're not going to give you scientific calculator, I think what they're going to do actually, they're going to be very careful with the values they are giving this year. They are going to be extremely careful with the values they are giving. All right. But till then, I'm going to teach you how to solve some questions, without your scientific calculator, and you still get your answer correctly. I'm going to teach you ways you're going to get your answer without punching a calculator. There's going to be a separate class for that. I'm also working on some tricks in mathematics. I'm going to be, many of you don't watch my videos. That's another thing. You only come for the live. Go to my page right now. If you're on this video watching this live, go to my page right now. Click on the subscribe button. Turn on your notification and set it in all. All right. There are videos I've uploaded on my channels. Go and watch those videos. All right. I'm working on some videos which I'll be uploading this week, God willing. Videos on how to find the value of sine, cos, and tan of 30, 45, 60, 0, and 90 with just your fingers. I'm going to be dropping that video. And only those who are my subscribers will be getting that video, okay? There's so many shortcuts I'm going to be dropping. And if you did not subscribe with me, how would you get this? You can't. All right. That's why you have to be a subscriber to this page, okay? Do where to subscribe. Do that. It's very important so that you don't miss out on any updates. All right. So in the next few seconds, I'm going to be cleaning this board because I need to give you the third question. There's no time. The third question that came out in 2023 will be dropping soon. This is the second question that came out. We are going straight to the third question. So if you're smart enough, you also write out the topics. Okay. We've solved the question under waves. We've solved the question under projectile motion. I don't know where the next one is coming from until you see it. All right. Secondly, please, I want to know how the audio is. I want to know if it's very, very loud because I'm using an external mic. So if the audio is extremely loud and you can hear me clearly, please type it there. Sorry. Sorry. Can I bring water for you? Can I bring water? Uncle, who did you? I forgot I was on my. You guys are very funny. I forgot I was on my, speaker. Yeah. Yeah, she's choking, so I had to just I had to go and attend to her. Many of you are very funny. It's my sister. Yeah, my elder sister, she's with us. She's choking. I had to go attend to her. Look at how quick you guys are to start typing. Yeah. No problem. It's okay. It's okay. The important thing is that we are learning. Yeah. I know you were joking. Obey, you're not feeling fine. You're not feeling fine. All right. I see you guys are catching enough fun. That means you're done with what is on the board. So at this point, I have to take it off. All right, so you know how we do it now. I have to go off and come back. Please do not leave the live so that I can put the third question on the board. So you can be gisting with yourself while I get the. All right, I'm back again. I'm back again. I'm back again. Thank you for all those who are still waiting. Come on, you guys have typed so many. Can you imagine? All right, I'm back. I'm back. I'm back. I was going through your chat and you guys are cracking me up here. So yeah, you have it. The third question that came out last year from Jam. The very third question. This message is heard for review. Someone just typed something that wasn't too good, and YouTube has held it for review. Please be very careful what you're typing here because this is a page that YouTube is actually looking at. Okay, I used to have one of the biggest page on YouTube many years ago, and I don't know, maybe because I'm doing this kind of niche, YouTube actually promotes more of entertainment than things that would help Africans and Nigerians in particular. And I was always penalized. So please be careful of the kind of words you paste here in order not to get blocked by YouTube, not me. All right. There's a particular message now that was held by YouTube. The camera is a bit blurred. Oh my God. Oh my God. What do I do? What do I do? Is it still blurred? I don't know. They don't want me to rotate it. If I put it this way, okay, let me ask a question now. If I hold this camera this way, is it very clear? No, my resolution is actually good. It's actually good. It's in fact it's in the high definition. I want to find out something. Holding it right now in portrait, is it very clear? I need to know. Someone should type something. Is it this way? Is it clearer than how it was before? The thing is, I actually gave a student my ring light and he misplaced it. All right. So, uh, he misplaced it. That's why you see I actually if I tell you what I'm going through here to keep this thing this way, you'll be surprised. It's still blur. See, it's not my resolution, it's your resolution. Okay, you go check your settings and increase your resolution. I think few students had this issue before, and they realized that it was actually their phone, not mine. So go and check your resolution. It's having issue, not mine. Still blur. Okay, I think I need to rotate it back since they are saying it's still very blur. There's actually no difference. So let's just keep it this way there. Let's keep it this way there. I was thinking there was a difference, but since there is none, let's just keep it this way. All right, let me read out the question for you guys. Let me read out the question for you guys. The half-life of a radioactive material is 12 days. The half-life of a radioactive material is 12 days. The half-life of a radioactive material is 12 days. Calculate the decay constant. Calculate the decay constant. Calculate the decay constant. So I'm going to read it again. The half-life of a radioactive material is 12 days. Calculate the decay constant. Calculate the decay constant. I should try cleaning the camera. Yep. Actually, the camera? I don't think so. Is it better now? I've done what you asked me to do. It kind of fell off because I had to remove the pad. I've done what you had to ask me to do. Samson, I've cleaned the camera. Class, was there any change in how it is now and how it was before? Okay, it's clear enough. All right. And I think I need to fix back I have to fix back my phone pouch, because if this phone breaks, it's Samsung. You know what Samsung is. So I don't want to take any chances. Okay. It is better. High spot rate better. Is this better? Is this better? You guys should say something. You guys should say something. Is this better? Or do we have to take it back to how it was before? Is this better, or do we take it back to how it was before? No. All right. All right. We are back. We're back, and we are back. All right. So let's get down to business. Option A is 0.8663 per day. B is 0.4331 per day. C is 0.17325 per day. And D is 0.05775 per day. I'm going to go over the options again. A is 0.8663 per day. B is 0.4331 per day. C is 0.17325 per day. And D is 0.05775 per day. So that is the question given to us, and we have to provide a solution to that question, okay? Please, if you are just joining us, hit the like button, share this video. Do that now, please. All right, so we are back again to question number 3. And actually, this particular question falls under the topic called radioactivity. Radioactivity is the disintegration of a radioactive substance to produce smaller nuclei, which we call the daughter nuclei. The one that disintegrates is called the parent nuclei, PN, while the one that is formed is called the daughter nuclei, DN. Okay, so that is essentially what radioactivity is all about. Okay, now radioactivity is different from activity. Please mind you, because some of you, when you get to your 100 level, which is also known as the A level, I'm going to be teaching you some things where Henry Becquerel is actually the man who discovered radioactivity, according to what we learned. I think Perrier and Marie Curie worked on activity itself, right? So the two are kind of a little bit different, all right? But let's get down to business. That's why we're here, and that's why we're doing this today. Now, we're told that the half-life of a radioactive material is 12 days. What this actually means is that half-life on its own is defined as the time taken for a radioactive substance to decay. To decay means to disintegrate, to half its original size or mass. Now, what do I mean by that? Now, take, for instance, Charlie Photon, for example. I weigh, let's say, 72 kg. Now, if I'm going to decay to half my mass after 2 days, it simply means that I'm not going to weigh 72 kg. Rather, I'm going to decay by half. And half of 72 is 36. That means that in every 2 days, I am going to be losing 36 kg. All right. That value is called the half-life. All right. So in this case, we're told that the half-life of this material is 12 days, meaning after every 12 days, the material is going to decay. Calculate the decay constant of this material. Calculate the decay constant of this material. So as usual, we start with antidote, and we always smile because we like it. Now, the first thing we are going to do is to understand the formula that would work for us here. Know this today. Whenever half-life is involved, there is a formula we use. The formula is giving us T subscript half. T subscript half equal to 0.693. 0.693 divided by lambda, all right, divided by lambda. So this is the formula for finding half-life. I repeat, T half, meaning half-life, equals to 0.693 divided by lambda. Now, this lambda is called the decay constant, all right? Lambda is called the decay constant. So that tells you that there is a constant for every decay, and that constant is represented by lambda. And the unit for the decay constant is actually per time. Per time. It could be any time. It could be in seconds, it could be in minutes, it could be in hours, it could be in days. For instance, now, we're told that this radioactive material is 12 days. That means that my decay constant is going to be per day. And that's why if you check the option, you see day raised per minus 1 is called per day. If the decay constant were to be, let's say, 12 hours, my options will no longer be having day raised per minus 1. Rather, my options are going to be having HR raised per minus 1. And that's what we call per hour. So right now we are dealing with per day. So let's go ahead and finish up this. I can see comments that I can't see. What's going on? Have you bothered to check your network? Have you done your setting on resolution? Can I go on? Please, I need to know if I can go on with this solution. I need to know if I can go on with this solution. Please type and let me know. Some are saying it's not too clear. They can't see. This is how we've been working. Please confirm if it's not too clear. You're saying it's not too clear. I don't know. This portrait, is it clear? I really don't know why you guys are having issues, because okay, I really don't know what to do, to be honest. I need you to confirm. Is this better? I should move the camera near the board. Is this better now? I've moved it near the board. Is it better now? Or do I still move it closer? Let me move it closer and see if we're going to achieve what we are looking for. How is it now? Is it better than before? All right. Okay. All right. So I think this is what you prefer. Okay. So since you say you can see it clearly, I think we can move on. So simply what I was saying is that there's a formula for finding half-life, and that formula is T half equals to 0.693 divided by lambda. The lambda is called the decay constant, and it's measured per time. In this case, our radioactive material had 12 days. So that was why you check the options, you see per day, per day, per day. All right, but that's not what we are looking for. We're told to find the decay constant. That obviously means that we are looking for what? Lambda. So I'm going to take this part off so that we could solve. Now, how do we get lambda? We simply get lambda by changing this position for this. Lambda will take the position of T half, while T half will take the position of lambda. Hence, our lambda will become 0.693 divided by t half, which is coming to the bottom. And that t half is called my half-life. And what's the half-life in this question? 12 days. So basically, I'm going to be dividing this by 12. All right. So let me quickly get my calculator. All right. So I'm simply going to press or punch on my calculator 0.693 divided by 12. And when I do that, I get as my final answer 0.05775. Okay, this is the answer 0.05775. All right, this is exactly what the calculator gave to me. Remember, I told you that the unit for the decay constant is per time. And what is the time we are dealing with here? Day. So I'm going to say day raised to power minus 1. And that means per day. All right. So let's check which of the options have that. Option D actually tallies with what we got. So D becomes your final answer. Thank you. Tessie, call again. You can't see it. Tessie, what's wrong with your phone? Tessie, click on settings. There's setting in your life. Click on setting, go to resolution and increase it. It's your resolution is low because every other person here can see it now. So click on setting, go to resolution and change it, okay? You can chat with some of these guys who are on this live. They'll teach you how to do it, okay? Please, if you're part of us and you've not still liked this video, please do that now. Click like on this video now. I am not satisfied with this like I'm seeing. Just 19 like is not really encouraging. If you know you're here and you've not clicked live, it's you being selfish and it's really not good. All right. So do where to click on the like button. Do where to share this video. Tap on the three dots on your screen. You see share. Share it to your WhatsApp status. Share it to your groups. Some of you are in groups in your lecture. Share it to those groups. Share it to your WhatsApp status. Share it to friends. Let them come and join us. Something is going on here. We are demystifying last year JAM question. It's not every day you wake up and get last year JAM question. I have it here with me and we are looking at it together. It's not something you keep to yourself. Share it with friends, okay? And please, if you're still here, you've not clicked this like button, do that now. If not, I might have to end this live channel because it simply shows that you guys do not appreciate good thing or what is free. So if you know you appreciate what I'm doing right now, click on the like button. That's all I ask of you. I didn't say you should pay. All right. All I said, I didn't say you should buy data for me. Okay. I just said click on the like button and share. That's all I ask of you. All right. So I think we can go over to the next question. I think you're done writing. On the day of your exam, many of you are really going to appreciate what we are doing here. You know, some persons are really going to regret why they did not join this live. I know what I am saying, but it will be too late by then. So please give me a few seconds. Stay alive or do not leave. All right, we're back. We're back. So please, I told you not to leave. I just wanted to get the question, okay? We are back. We are back. It's not network. I only went to get the question on the board, okay? The question is on the board now. Please, you can start writing. I only left to get the question, okay? Please, if you are back online, just type I'm back. All right, so we're back. We're back. I went to get the question. So this is a much more difficult question. Just imagine the students that have missed tonight's class. Just imagine. Or imagine you are the one who missed this class. Just imagine seeing this question on the day of your exam. What will you do? That's why I'm here with you, because I want you to pass. I want you to succeed. And I want you to teach others so that they can respect you. All right, please, I'm giving you a few seconds to quickly write down the question on the board. I believe by now you should be done writing the question, okay? So I'm going to quickly dictate the question, all right? A wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 1.5 kilogram. Determine the Young's modulus for the material of the wire. I'll go over it again. A wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 1.5 kilogram. Determine the Young's modulus for the material of the wire. And you are giving G equals 10 meter per second square. And you have options 2.4 times 10 raised to power 10 Newton per meter square. You have 1.5 times 10 raised to power 10 Newton per meter square. You have 2.4 times 10 raised to power 9 Newton per meter square. And you have 1.3 times 10 raised to power 10 Newton per meter square. So there you have it. Please like this video. Please like this video. I just got a call right now. There's something I need to attend to. So this is probably going to be the last question we are solving tonight. But I'll try as much as possible to organize another session of this tomorrow. All right? I'll try my possible best. And I'll be in the following lectures tomorrow. I'll be in landmark lectures. I'll be in Cambridge tomorrow. I'll be in Solid tomorrow. Okay, so expect me. All right, so we're going to be stopping after this question, and you don't want to miss this last question. This is something you take back to the class, and you can use it to show yourself. Okay, so we're told a wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 1.5 kilogram. Determine the Young's modulus for the material of the wire. Okay, so let's get straight into this question and see how we can get the answer to this question. All right, so I want you to look at this question carefully. We have our antidote as usual, and we start bringing out the parameters linked to this question. Now, you were told that a wire of radius 0.2 millimeter, that means the first information we're given in this question is the radius. Radius is represented by R, and the value is 0.2 millimeter. Now, the word milli means 10 raised per minus 2, and you and I know that the standard unit is supposed to be a meter. So what this means is that 0.2 times 10 raised per minus 3 meter. And 10 raised per minus 3 is like saying 1 over 1,000. All right. So this becomes 0.2 divided by 1000, and whatever we get is going to be in meter. All right, so we have 0.2 divided by 1000, and that gives us 2 times 10 raised per minus 4, which simply means 0.0002, sorry, 0002, all right, meter. That's 1, 2, 3, 4. So when you convert 0.2 divided by 1000, you get 0.002 meters, okay? So whenever you see milli, what they simply want you to do is to divide the value by 1000, and you get the consequence conversion in meter, all right? So let's go on. They said it was extended by 0.5%. The word extended means extension. By what percentage was it extended? 0.5% of its length. Mind you, we don't know the length. If you look at this question, the length was not given. But we're told that this particular material was extended by 0.5% of its length. Now, this is what you do when you see this question this year. Now, do not tell anybody this. Now, this is what you do. You're going to tell them letter E stands for extension. It was extended by 0.5% of its length. So since we don't know the length, we're going to be representing the length with letter what? L. Now, what does 0.5% of length mean? Or what does 0.5% of L mean? It means 0.5, percentage means 100, divided by 100, of means multiplication, and what? L. So we are going to divide 0.5 by 100. All right, so that becomes 0.5 divided by 100, and that will give us 5 times 10 raised per minus 3, which is the same thing as 0.005. Then automatically you have what? L. So this is the value of the extension E, 0.005 L. That's the extension, all right? So they went on to say, sorry about that. Please, can you hear me now? I think my speaker went off. Can you hear me now, please? If you can hear me, please signify, please. Can you hear me now, please? I told you I was using a speaker, so it went off. It went off. So I'm sorry about that. Okay, so let's get back to business. Recapitulate. Wow, please. At what point did you stop hearing me? Because I know you heard about the extension, you heard about the mass. I just wanted to give you the formula for Young's modulus before it went off. So at what point did my voice go off? Please like this video. Please, if you are here, you've not liked this video, please do that now. If you are here and you have not clicked the like button, please do that now. Do that now. Godwin, I can't start all over now. Thank you. I wanted to give you the formula for E. I could remember. Okay. We've not really done anything. I can't start again. You guys are not even supporting me. You're not liking these videos. You're not making it go to others. You're not even doing anything. All right, now E is extension. They told us it was extended by 0.5% of the length. All right, so we divided 0.5 by the percentage, which was 100. 0.5% of means multiplication, length is length. 0.5 divided by 100 gave us 0.005. So we multiplied it by L, that's why you have this. The next thing they gave us was the mass. The mass was 1.5 kg, and that's what you have here. Then they also gave us the gravity, which is G. 10 meters per second square. Then they went on to give us something that they want us to get. You know, the question asked us to look for the Young modulus, all right? Now, Young modulus is actually represented by letter E. I now said that some textbooks prefer to use this symbol. This symbol is called the gamma symbol, right? But I'm going to be sticking with E. So what does Young modulus mean? Young modulus is represented by E. Now, what is the formula for Young modulus? Young modulus is giving us stress over strain. That's the formula for Young modulus. Stress over strain. Now, what is the formula for stress? Force over area. That is the formula for stress. Divided out. What is the formula for strain? Extension over length. So the formula for stress is force over area. The formula for strain is extension over length. And what this simply means is that force over area is dividing extension over length. And you know this mathematics gimmicks. Your division becomes multiplication, the E comes down. So this becomes force over area multiplied by length over extension. And if you bring them together, we have force multiplied by length divided by area multiplied by extension, all right? So there you have it, okay? Force length divided by area extension is the formula for Young modulus. Now, where did we get force length divided by area of extension from? We got it from stress over strain. By giving us the formula for stress as force over area and giving us the formula for strain as extension over length. So force over area was now dividing extension over length. And the moment division became multiplication, length went to the top, extension came down. It became force over area times length over extension. Force times length will give us force length. Area times extension will give us area extension. So we have force length divided by area extension. I think that's clear enough. All right. So the next thing we are going to do now is to see if we have all this. Now, do we have the force? Look at all the parameters. There is no force. But I do know that the formula for force is mass times gravity. And I know that the value of my mass is what? 1.5. And the value of my gravity is what? 10. So if I use 1.5 to multiply 10, I will get 15. What is the unit for force? Newton. So I've gotten my force. Now, do I know my length? No, I don't. And there is no formula to get length. Do I know my area? If you look at all the information produced here, I don't know my area. But I know that this was a wire. And a wire is a cylindrical object. Not just it being cylindrical. The top of the wire is what we call the surface area. And the surface area of the wire is a circle. So how do I get my area? I will get my area by using the formula for finding the area of a circle, right? Now, what is the formula for finding the area of a circle? The formula is pi r squared, all right? Now, what's the value of pi? The value of pi is 22/7. What's my radius? Did they give me anything about radius here? I'm not too sure. Did they give me my radius? Someone should check and see if our radius was given. I want to be very clear. Let me look at that question. Sorry, you guys can't hear me again. What's going on? Is it that you can't hear me again? I'm lost here, please. Someone should help me out here. What's going on? Do I continue? Do I continue or do I stop here and leave it for you to finish up? Radius was given. Thank you. Yes, I remember radius was given, but I cleaned it off. Can someone help me with that value? I know the radius was given, but I cleaned it off. 0.2 millimeter was the radius. That's true. We converted it already. Yes, we divided it by 1,000. I remember. And the radius was 0.0002. Yes, the radius was given. If you check before I clean this, the radius was converted here. So I'm going to open a bracket and put the radius 0.0002. That was the value of the radius. Then I close it, then there's a square here. All right. So whatever I get here is going to stand as my area. All right. So let me get my calculator. Thanks, Obi. Now, I'll start with finding the square of what is in my bracket, 0.0002. Find the square, I get an answer, then I multiply it by 22 over 7. 22, I get an answer, divided by 7, I get an answer. And the answer I'm getting as my area is 1.257 times 10 to the power of minus 7. All right? When you punch all this in your calculator, this is what you get. And the unit for area is meter square. Meter square. So at this point, I think my work is done. The only thing I need now is to fix all this value into this formula and get E. E is called my Young's modulus. You can see how stressful this is. But you see the way I've been able to resolve it so that it can help you get better and save time. So the Young modulus will now become force over area extension over length has given us force length extension what area. So that's FL divided by AE. So let's fix in the value. What is force? The value of force was what? 15 Newton. I'm going to place 15 multiplied by, I don't know my length, so I'm going to write L. Divided by, I remember my area. What did we get as the area? 1.257 times 10 to the power of minus 7 multiplied by the extension. Remember we solved for extension. And what did we get as our extension? 0.005. Then there was an L attached to it. And this will become, the L here will definitely cancel out the L here. So all I need to do now is to punch all this into my calculator, and whatever I get becomes my Young modulus. All right? Take note again, the unit for the Young modulus is Newton per meter square. The unit for Young modulus is Newton per meter square. Take note of that. All right? Now, let's do that. I have 1.25 times 10 to the power of minus 7 multiplied by 0.005. I get an answer. Then I use 15 to divide my answer, and that gives me 2.4 times 10 to the power of 10. 2.4 times 10 to the power of 10. I told you that the unit for Young modulus is Newton per meter square. Newton per meter square. And that becomes our final answer. That becomes our final answer. And I'm very sure we have this in the option, although I cannot really tell. Please, someone should type the option that matches with this for us. I want someone to confirm the options that matches with what we have there. If you're with me here, please type the options that matches with what we have in the box there. Option C, thank you. So the correct answer to that question is option C. Option C. Obey is saying option A. Why is there a conflicting answer? Please check the power very well. The power is a positive 10. So I'm going to give you a minute to write out everything Okay, option A. Okay, option A. Thank you very much, Obey, for the correction. The answer is actually option A. So I'm going to give you a minute to write down everything we have on the board. That is the solution to that question. All right. Thank you so much for paying so much attention. For those of you who use data, I'm very, very sure you did not regret coming for this class. It's been a wonderful 1 hour, 9 minutes with you guys. And I'm very sure you might have learned a thing or two from this. And I'm going to try my possible best to make sure I be with you guys tomorrow. We'll keep doing this every day. I will try my best to keep doing this to the very day of your exam. It's not really easy. So whatever support I can get from you, I'm always open to those support, okay? So, but please, the only thing you can do for me for now is to like this video. If you really, really benefit something from this video, click on the like button, share this video, all right? So I just want to remind you all that I love you all. I love you all. All right, so I think I've done enough. I love you all. Godwin Onusi, Chichi, Winters, Obey, Tessico, Official Charles, Samson, Umimu, Olise Kelvin, Osarobo Blessing, countless of them all that has been with us here from the very start till this very moment. Samson, Uminu, Ogbuja, Chidinma, who else? Alon, Promise, AGK. We also had Psycho, my good Psycho. We had Obey. We had, many of them. They've been with us from the very start. Imaru Isaiah, we had Daddy Springs. We had, from the very first start, we had Celestina. We had, also we had, who else? We had many of them. And for all those who commented on these videos, for all those who liked the videos, for all those who shared the videos, you all you're wonderful. Nicolo FB, I don't know if that's Facebook, something of that nature. We also had, I think that's about it. You guys, you're amazing, you're wonderful. And trust me, your exam is going to bring out results that the world has never heard of before. Grace Osamuje, before I forget, Grace Osamuje was also there. So I love you all. Photon loves you all. Charlie Photon is always with you, and we'll continue to share the set, all right? The set will continue to go far, okay? So do well to share this video at the end of this video. I'm going to be going off live right now. I just want to thank you all for being with me to the very end of today. I love you all. Thank you so much.